So we're going to do a little bit of a delta G review to understand thermodynamics. And look, I'm giving you three different equations all at once. I'll explain them one by one. This video will take a little bit of time just on the explanation alone. But the delta G is about spontaneity, okay? And there's three ways it manifests itself. Now, if you look at the top equation on your screen, you have delta G is equal to these numbers, and then at the end it ends with this E. That's called an E cell. That is actually electrochem right there. You have this delta G that ends with a K, and that K is equilibrium right there, products over reactants. And then you have this delta G, which deals with enthalpy and entropy, delta H and delta S. So what I want you to also realize is that these can cross, like they can cross over. Like you can make both, like the top equation and the bottom equation, you can set them equal to each other because they're both equal to delta G. So like you can find out what an E cell means in terms of entropy, or what equilibrium means in terms of E cell. Like there's so much mix around that can happen here. It's a very creative, it provides a very creative opportunity for the writers of the AP exam to come up with really good questions. All right, let's look at this delta G. We'll start with the enthalpy one. Now, it's really important that you understand what delta G is. Delta G is what we call, and let's get a green, oops. Delta G is what we call spontaneity, okay? It determines whether the reaction is spontaneous or not. Now, when you think of spontaneity, don't think of like someone who's like going to eat at Denny's at 3 in the morning. That's not what spontaneous means in terms of chemistry. In terms of chemistry, spontaneity, a positive delta G means you are not spontaneous. A negative delta G means you are spontaneous. Spontaneous in terms of delta G means whether or not the reaction needs help. Okay, so if you have a positive delta G, you are not spontaneous. You need help for this reaction to occur. Delta G, if it's negative, means you are spontaneous, meaning you no longer need any help. Let me give you an example of something that is spontaneous. The rusting of metal is a spontaneous reaction. Is it occurring very fast? Is it happening right away? No. So don't think of spontaneous as something to do with like an instant or just really quick, you know? That is not spontaneous in terms of chemistry. Spontaneous is whether or not it needs help. And when you combine iron and water, eventually it's gonna rust, okay? All right, let's take a look at delta H. Delta H, you might have learned this from your therm. Positive delta H means you're endothermic. It means heat is a reactant. You might remember that from your Le Chatelier seesaw. And you have delta H, when delta H is negative, it is exothermic, meaning heat is a product. Minus T, which is Kelvin, delta S. The one thing about Kelvin that needs to be said here is that you need to remember the reason why we have Kelvin is because Kelvin makes our math possible. Kelvin cannot go to zero. You cannot go to zero with Kelvin. It is always a positive number. Now delta S, entropy. Okay, entropy is. Oh, sorry. Delta H is enthalpy, and delta S is entropy. Okay, entropy can be said as disorder. How much disorder is there? And now you got to remember, this is a delta S. This is a change in entropy, not necessarily a state of matter. But I like to say that when you become a gas, you have positive entropy. You are increasing in your disorder. When you are becoming a solid, you are losing entropy. Your change in entropy is negative, and you are now having more order, less disorder. Okay, so I say gases are like grandkids, solids are like grandparents. This is an analogy that I'll use to help you understand this topic. Okay, but I want to make let's dive into this particular equation. Okay, so delta G is equal to delta H minus T delta S. So if I want a spontaneous reaction, I'm going to say that, okay, if I want a spontaneous reaction, this right here, I want a negative delta, delta G. I want a negative delta G. To get a negative delta G, a perfect scenario would be is if I had a negative delta H and a positive delta S. Now think about that. Okay, so you guys are gonna, so you're gonna put this like a negative into delta H. Ooh, let me change that. You're gonna put a negative into delta H minus some number T times a positive. So since T has to be positive all the time, you're going to do this. A negative minus a positive. A negative minus a positive is guaranteed to be what? Negative. That's right. It'll be spontaneous. Okay? I don't know who I'm talking to. I think I'm just talking to myself. Okay. Now, another scenario where you're always going to be something, in other words, positive. If you have a positive delta G, you want to have a positive delta H and a negative delta S. So if you have a positive delta G, you're going to subtract a negative delta S, or I should say T delta S, and a positive minus a negative is always going to be a positive. Okay, so these are the two scenarios where you are guaranteed, to have either spontaneous or not spontaneous. Like it can't become the other thing. Now, the real part that gets pretty tricky. Move this away. The part that gets tricky is when you end up considering like you have a mix of things. Okay, so let me erase a lot of this. What if you have a positive delta H and a positive delta S? If you have positive delta H, positive delta S, you could be positive or negative in your delta G. It depends. So now I don't want to say delta S. I want to say T delta S because T is the thing that affects this. Look, if you have a positive delta H that's bigger than your delta S, like it'll cancel out the T delta S, right? But that is only if your T is really small, right? If T is really small, okay? But say you have the same exact scenario. You have positive and positive, right? You have a positive delta T, you have a positive, you have a positive delta H, you have a positive delta S, and you have a gigantic Kelvin. You have a gigantic temperature. Then your T delta S, your T delta S will overcome your delta H. Well, if you have a positive minus a really big positive, then you will actually turn out negative. So look, just remember this. If you have a positive and you have a small temperature, you are going to become positive because the delta H outweighs the T delta S. But if you are positive and you have a giant temperature, you're going to have a positive minus a giant positive number. You are going to be negative because the T delta S outweighs the delta H. Okay? So you got to think of how temperature affects, let me show you. How does temperature affect this side of the equation and this side of the equation? Or I shouldn't say this side of the expression, right? If temperature is large, it makes the delta S more important. If temperature is small, it makes delta H more important. So there's always kind of a struggle there, a tug of war that's going on. Okay, and this is true when it's negative as well, delta H and delta S. When delta H and delta S are negative, both negative, you can have a positive delta G, you can have a negative delta G. It kind of depends on temperature. So here's your first delta G. This is the one that deals with enthalpy and entropy. Okay, remember, spontaneous is, does the reaction happen on its own? Does it need help or not? Delta H is whether it's endothermic or exothermic, heat is a reactant or heat is a product. And then delta S is the change in your disorder. And remember, this is, if you're like a gas going to, a gas, that doesn't work. I mean, this is not a good analogy, but for the most part, this is going to suffice, okay? All right, so let's get all this stuff out of the way. Let's move on to the next delta G. All right, now you have this delta G. Now, again, delta G, if it's positive, it means you are not spontaneous, you need help. And if you are negative, you are spontaneous, you don't need any help. And again, remember, spontaneous, I can't emphasize this enough. Spontaneous is not how random you are. It is whether you need help or not, okay? All right. Delta G is equal to negative rat link, okay? RT ln K. Now, let's see. This R right here is equal to 8.31 joules per mole K, and I'm gonna give you that unit for a specific reason, because rat link RT ln K is in joules. I'm just gonna let you know. Oh, I should have said this in the last one. Delta G is generally in kilojoules. Delta H is generally in kilojoules. And delta S is normally in joules, okay? So that's something that you always kind of got to watch for. You got to convert your delta S to kilojoules, okay? All right. Now, here you see, again, I told you delta G is negative, delta G is kilojoules. And RT ln K, so R is in joules, so you're going to always have to convert here to make sure that those units cancel out, okay? Now, temperature, again, is in Kelvin, and again, the important thing about temperature being in Kelvin is that Kelvin can never be negative. It's always a positive number. So if you notice, if R is a positive number and Kelvin is a positive number, then RT will always be positive, okay? R times T will always be positive. It will never be a negative number, okay? So that's one thing that you got to take away from this portion right here, okay, is that these guys are always positive, okay? Now, obviously, there's a negative sign in front of it, okay? So now, whether delta G, okay, you don't treat these equations like I need to know the numbers to put in. The numbers are kind of secondary. On some questions, you will have to calculate, but very few, because these questions are more about, is the delta G positive or negative, and how do we know that? All right, the last part of this is the most important part. This is the ln K. Ooh, what am I doing? Okay, this is the ln K. The ln K is, okay, let's just talk about log, okay? So products over reactants, okay? If your K is greater than 1, you have more P. You have more product. If your K is less than 1, you have more reactants, right? Like you have more denominator than you have numerator. So, okay, I want you to mess around with your calculator and take the log of a couple items, okay? If you take the log of 100, what do you get? If you take the log of 10, what do you get? If you take the log of 1, what do you get? Okay? And then if you take the log of, let's say, -1, okay? Well, if you take the log of 100, you will get 2, okay? Because this is saying 10 to the 2 is equal to 100, right? If you take the log of 10, you will get 1. If you take the log of 1, you will get 0, okay? Now, if you take the log of -1, you will get an error, okay? If you want, but how do you get a negative number from something like this? Because that's all we really care about. Because we want to know, will my delta G be negative or positive? And if R and T are always positive, then the only thing that determines whether delta G is negative or positive is the ln K, because this negative times this positive, is it going to be multiplied times a positive number or a negative number? That's the question. So when you're doing your ln K, you have to get a negative number, you take the log of a fraction. Okay? So think about what that means. If you have more products than reactants, okay, if you have more products than reactants, then you will get a positive number from your LNK. If you have more reactants than products, you will get a negative number from your LNK. Okay, so let's deal with these numbers one more time. Let me give you the two scenarios. All right, if I have, okay, let me kind of clean this up so we're not confused here. Okay, so if I have more K, okay, if I have a lot of, let me move this down a little bit. If I have a lot of product, okay, that means my K, that means my LNK overall became what? It became positive. So then I have a positive times a positive times a negative. A positive times a negative means it is negative. Okay? It is spontaneous. Okay? Let's work out those numbers again. What if I have less than 1K? What if I have more reactant? Well, then I have the LNK turns out to be a negative number. And a negative number times a positive number times a negative number becomes what? Positive, not spontaneous. Okay, why is that important? How does that, now think about how logical how much logical sense that makes. Okay, if I have a positive K, I have a negative G. Okay, if I have a positive K, I have a negative G. So what does a positive K mean? It means I produce a lot of products. What does a negative delta G mean? It means I am spontaneous. I need no help. Okay? If I have, okay, let me try to show you. If I have a positive K, I have a negative delta G. Yeah? In other words, I am spontaneous. I don't need any help if I produce a lot of products. That makes so much sense to me because think about this. Think about the other side. If I have a negative LNK, then I am not spontaneous. If I don't produce a lot of product, if I don't produce a lot of product and I produce a lot of reactant, then I need help. My reaction is not working. I'm not going forward. So this is the easy way for me to memorize it. Okay, it's kind of the opposite. So let me show you my labels here. This is my delta G. If I have this is my delta G and this is my LNK. Okay, if I have more products than reactants, I'm spontaneous. If I have more reactants than products, I'm not spontaneous. This is a pretty tricky one, but the logic here is really, really good, and you got to know how to manipulate a logarithm here. Generally, you just need to know that a logarithm, if you want a negative number to appear, you have to have a number less than 1, but not a negative number. Okay, so a logarithm is a fraction. Okay. All right, last one, and okay, these are a beast. Okay, so the delta G unit is kind of my favorite unit because this is where it gets really tricky. Okay, so here you have delta G is equal to NFE. This is electrochem. So before we can even discuss electrochem, you need to know what an oxy-reduction, or what we call a redox reaction is. Let me give you an example. I picked two things here. I actually don't know if these were good choices, but all right. So the Cu is becoming, the Cu2 plus is becoming Cu. Okay, the Fe is becoming Fe3 plus. So I want you to think what's happening here. Cu2 plus to become Cu neutral, right? The Cu ion to become Cu atom, right? It must have, it was positive, now it's neutral. So what did it do? It gained an electron, okay? It gained an electron. Gained Okay. Now, what did the Fe do? The Fe, on the other hand, it was no charge and it became positive. For it to become positive, it lost negativity, right? So it lost. Now, the phrase that you guys will learn, and some teachers say Leo goes grr, I say oil rig. Okay, and you know what? Deal with it. So this is oiling, while this is rigging. Okay? So Fe is losing electrons. Copper, in this case, is gaining electrons, or copper 2 plus is gaining electrons. So we say oil rig. Oxidation is the loss of electrons. Reduction is the gain of electrons. So now I know that copper is reducing, and iron is oiling. Okay, copper is reducing, iron is oiling. Okay, they are. This is the concept that is going to help us understand everything. Now, there's another phrase that you need to know. Anox, red cat. Okay, anox, red cat. I actually don't. I teach my students anox, red cat because I think it helps them. I just think of it as anode and oxidation are both start with vowels, and reduction and cathode both start with consonants. So, the anode takes place where oxidation occurs, and where reduction occurs is the cathode. So anode and cathode, that's what we're talking about when we're talking about electrochem. Now, the anode and cathode, if you want to think about it, they're two electrodes, okay? One of them is where your, one of your electrodes is where oxidation is occurring, and the other electrode is where reduction is occurring. All right. So here we go. So delta G is equal to negative NFE. Now this is very similar to the negative rat link, right? Again, we're talking about delta G. So when we talk about delta G, we're talking about if delta G is positive, the reaction is not spontaneous, it needs help. If delta G is negative, the reaction does not need any help. It'll happen on its own. So you have the negative N, and N here is moles, okay? Kind of like our Pivnert, okay? So N is moles, okay? That you can't have negative moles. That's always going to be a positive number. F, and sometimes it's written in this like really nice cursive F, is called Faraday's constant. Okay, Faraday's constant is 96,485 coulombs per mole of electron. Now, it's just a big number, okay? It's basically 100,000. And generally when I do calculations with it, I'm generally going to estimate with 100,000 unless I have my calculator. Even that is a little bit, 96,500, how about we say that? But anyways, okay, so look, moles has to be positive. Faraday's constant is positive. So again, NF will always be a positive number multiplied by that negative number up here, right? So what determines whether delta G is positive or negative is what E cell is, okay? Now, an E cell, okay, E cell is equal to E cell is equal to your E of your cathode minus your E of your anode. And before you go and try to memorize a table on this, don't bother. Okay, let me just explain this. Okay, so E cell is equal to E cathode minus E anode. Now, if your cathode is greater than your anode, yeah? If your cathode is greater than your anode, then you know what? Your E cell is positive, right? Because you're minusing your cathode. You're minusing your anode from your cathode. So if your anode is smaller than your cathode, then you're going to have a positive number here. But if your cathode is less than your anode, that is going to become a negative E cell. Now let me tell you about the cathode being greater than your anode. The cathode being greater than your anode, this is known as a galvanic cell. Okay? Now, and if you have your cathode is less than your anode, you have a electrolytic cell. Electrolysis. All right. So, all right. Let's just think about this again. So, if you want a negative delta G, you already have a negative number with the NFE, right? The negative NFE. That's going to give you a negative number. So what do you want your cathode to be? You want your cathode to be greater than your galvanic cell, because then you'd have a negative times a positive times a positive times a positive, which a negative times a positive positive will become will become negative. And your reaction, therefore, will become spontaneous. However, if you have a non-spontaneous reaction and you have a negative times a positive times a negative, you will have a non-spontaneous reaction. So galvanic cells, are spontaneous. They have a positive they have a positive E, so they have a negative delta G. An electrolytic cell, on the other hand, is negative. So a negative delta electrolytic cell will create a positive delta G. So again, let me kind of try to clean this up a little bit. The way I like to think of this is if you have these two things, and now I realize that was a terrible color to try to get all that with. A non-spontaneous reaction that needs help is an electrolytic cell. It is negative. And a spontaneous reaction that needs no help is a positive E cell, where your cathode is greater than your anode. This is a galvanic cell. Now, let me give you just two things about an electrolytic cell and a galvanic cell before we end this lesson. All right. An electrolytic cell, one, will need help. Yeah? And not only will it need help, an electrolytic cell, an electrolytic cell needs help, and there's two things about it. There is no salt bridge. And you don't know what I'm talking about, but you'll see it. There's no salt bridge. And the other thing is that help comes in the form of a power supply. That is an electrolytic cell. You're going to be able to look at a problem on the AP exam and instantly tell whether it was a electrolytic cell or a galvanic cell just based on the fact that it has a power supply or not. Okay. Now, a galvanic cell, obviously, no help. It'll happen spontaneously. There is a salt bridge. And there is no power supply. Why is there no power supply? Because it doesn't need any help. Okay, it's happening on its own. An electrolytic cell will make it go backwards. Okay, I think we're pretty good there. Let's get to the questions.